Hello, my name is Armin Briegel. I work as a consulting engineer at Jamf in the European or EMEA region, but you probably also know my name from the weblog Scripting OS 10, which I've been running for quite a while now. Today, I want to talk about using Swift with the Jamf API, and there will be a lot of references to documentation, especially by Apple, to sample code, and to websites out there that help with this, from Jamf and others. You don't have to take notes, and I didn't want to mess up the slides with ugly URLs, so I will put all of them on a page on my personal website, scriptingos10.com/JNUC 2022. That's the only URL you have to remember and to copy. Everything else will be linked from there, and in the future, when the video is available, I will put that there as well, so that everything is in one place. So the topic for today is use Swift with the Jamf API. And I am not going to focus on the Jamf API. I assume that if you are here and interested about Swift with the Jamf API, that you already know why you would want the Jamf API, what it's good for, what you can do with it, how you can access it, where you can find documentation for it, and so on. I will put links to this in aforementioned doc, and I will also link a few awesome presentations by other people at JNUC this year and from the previous year that all talked about the Jamf API in much more detail. We will not go into much detail for the Jamf API. Some of it, but not much. What we are going to focus on is using Swift with the Jamf API. So I think the first question we need to answer is, why should we use Swift? And what is Swift? Well, Swift is a relatively new programming language. It was introduced by Apple in 2014, and it made its debut in macOS Yosemite and iOS 8. Sounds like it's long ago, and it kind of is. In the beginning, Swift was a bit volatile. Every update, every major update would basically break the previous code. And that's kind of expected from a new programming language. And you have to work with that and work around it. But people were very hesitant for that reason to actually use Swift in their projects and to actually invest into learning Swift, because if next year you have to relearn everything again, then why should I bother? That all kind of changed and settled down quite a bit in macOS Catalina and iOS 13, because that was when Swift 5 was released. If you want to be very nitpicky, Swift 5 was released with Mojave 10.13.4, in the spring release, and then we got 5.1 with Catalina, but that's the time frame we're talking about. Since Swift 5, we've still gotten regular updates, actually 2 a year for Swift, but they haven't been breaking. They're backwards compatible. Code that you write with Swift 5 will still run and compile with the latest Swift 5.6 or with Swift 5.7 that will come with Ventura and iOS 16 in the fall. They make great care that these things aren't breaking and the Swift code stays compatible. That makes it easier to invest into your code and to actually learn the code because, it stays more stable. It can work. That said, they are still introducing new features, and some of these new features are really useful and really interesting. And one feature that I will mention later was introduced last year with Monterey in iOS 15 and Swift 5.5. So if you want to use these new features, then of course you give up the backwards compatibility and have to focus on the operating systems and the Swift versions that go forward. In addition to Swift as a great language for all the Apple platforms, Apple has also in Catalina introduced SwiftUI. And SwiftUI is, as the name implies, a framework for writing user interfaces. It's built on top of AppKit on macOS and UIKit on iOS, but it's the same on both macOS and iOS, or mostly the same. It's actually the same across all Apple platforms. So whether you write for watchOS, tvOS, iOS or iPadOS, and macOS, SwiftUI is mostly the same except for the very platform-specific features. And It's relatively young. We will get the 4th iteration with macOS Ventura, but that means it's not quite as feature complete as AppKit or UIKit yet. But every year we get new features added to it, and it has become very, very useful. The idea is it is native Swift. AppKit and UIKit were originally written for Cocoa, and while there is a great Swift bridge for these frameworks, you can tell that some of the paradigms and some of the ideas in the framework don't really match the Swift philosophy very, very well. It works across all Apple platforms. It is very deeply integrated with Xcode. And what distinguishes SwiftUI from AppKit and UIKit very much is it has a declarative syntax. That means that every piece in my code reflects an object in the UI and vice versa. And I can have a direct relation from this piece in the code creates a text object or a text field object or a button. And it goes both ways. And I can see this even more distinctly in Xcode, because in Xcode I have a live preview of my SwiftUI representation and my SwiftUI code. And when I select objects in the preview, it highlights the corresponding piece of code, and vice versa. If I select a piece of code, I can see what it represents in the UI, and I can even modify in the inspector attributes and features of the text field. And if I change it in the code, it will reflect those changes. If I change it in the inspector, it will reflect those changes in the code. It's a very dynamic way of creating and visualizing, and I don't have to memorize all the weird code pieces because I can just go into the UI, select the right thing and change it, and then go back and work into the code. Or if I'm already in the code, I can keep working in the code. And that's pretty powerful. So SwiftUI was introduced with Xcode 11 and macOS Catalina, but as I said earlier, we are going to use some features that don't work in macOS versions earlier than Monterey. So the code we are going to build today will work in Xcode 13 and higher and macOS 12 Monterey and higher. What are we going to do? Well, first of all, we're going to build a command line tool that will interface with the Jamf API. We're going to list the computers in the Jamf API, or at least some of them. This is a very simple example, and of course, we only have limited time, and it's a complex enough task as it is. So this is my starting point. I like to start with command line tools because, as you will see later, building user interfaces brings its own levels of complexity, and they can get horribly complex, horribly fast. So when you work on a command line tool, you kind of have a UI, the text output, and maybe the input with the arguments, but it's a very simple UI. So you can kind of ignore that and focus on how to get the data in and out of your code and in and out of the Jamf API in this case. And that's why I think command line tools are a great starting spot. And after the command line tool, we will build a UI application, a macOS application. In SwiftUI. We will reuse the code we built for the command line tool for the macOS application. So these are the two things we're going to do. They will be in the same project. They will be very close together. We will reuse code. I said I wouldn't go too deep in the Jamf API, but there's one thing I do have to mention. This is a fairly recent change. Whether you use the classic API or the newer modern API or Jamf Pro API, we need to authenticate. And to authenticate to the system, this is the new thing, especially if you've been using the classic API, you need to get a token. You use your first API call, which uses the basic authentication, to get a token, and you need to use the token for authentication for the subsequent API calls. This seems like a bummer at first because, well, it's an extra API call that I have to do. But the good thing is we can use this call for the first to get the token. It's already an API call. We can use this as our example to get started. Because once we figure that one out, everything else is just a slight modification. Most of us who are here as Mac admins are probably familiar with using the Jamf API using shell scripts. And that's why I have sample code in shell script here that'll just walk through to explain the basic steps. I'll zoom in a bit to make it more readable. Before we do it, and this is all in shell scripts, we take the username and password and do a base64 encoding on them, and we take the Jamf URL, which is https something jamfcloud.com, and assemble the Jamf API endpoint to it and put it together. We create the data we need for our request. Then we send the request. On the shell, I use curl. Curl does an HTTP request to some server and gives me the output, which I'm storing in a variable here. And we make it silent because I don't want to see all the UI. We make a post request because that's what the Jamf documentation says we need for this. And we add our password that we prepared earlier, our encoded password, in a authorization basic header. If this command fails, we have to handle that error. In this case, I'm just like printing out, oh, we got an error getting the token, and we exit with an error code of 1. This is the shell, and that's what I meant with, handling these things in the UI is much more complicated. In a shell script or a command line tool, we can get away with simple error handling, but we need to do it. What we get back from this command is JSON data. That's JavaScript object notation. It's very common these days for APIs to return JSON. On macOS, unfortunately, we don't really have a good tool to parse JSON. You can install something like JQ or JPT or something like that to parse that, or you can use the built-in tools. Starting in Monterey, and it's good that we restricted ourselves to Monterey earlier, because now we can use this. We can actually use the plutil, the plist utility command line tool, to extract something from a JSON. And in this case, we want the token field, which has the long string that is our authentication token. And we can extract that from the JSON. But there are different ways of doing it. You might also use JavaScript for automation or something like that, depending on which version of macOS this has to run on. This is all together. Very simplified, but this works. This is our first API request, and it will get us the token in shell. Now, how do we do this in Swift? Let's look at all these 4 steps and how we do them in Swift. And you will see it's not that different. In Swift, first, we take the username and the password variables, and we encode them in a base64 string. The code looks a bit more complicated in Swift, but it really isn't, and it does the same thing. And then we assemble the URL. I'm using a class called URL components here. There is a simpler class to do this, but the URL components is very useful in this case, especially later when we have more complex API requests, where we have to add queries, the things with the question marks and the ampersands in them. That's where URL components gets really, really strong. So I recommend using URL components, even if this is a bit more complicated. And we can just take the server string and the path and put them together, and URL components will take care of all the string escaping and all the other rules that have when assembling URLs. And that's really nice. The next step is to send and request the data. And in Swift, we have an object called URL request and another object called URL session that does this for us. Most of the work is actually done by the URL session, but we have to put together the URL request. And if you look at that, that's very similar to putting together a curl command. We give it the HTTP method, which is post. We add a header value for the basic authorization field with the string we encoded earlier. And then we send the command to the URL session and say, I want the data that comes from this HTTP request. And there's something in here which is really, really amazing and really cool. And that's this await tag, because that will send off the URL session request into the background in a multi-threaded, multitasked way. And if you have a UI app, it will go into the background. Your code will wait at this point, but other code in your app can still run and execute. And when the URL session comes back with the data, your code will resume right after this command with the data you got back from the URL session. And that's a really, really nice thing. So it allows us to do concurrency. This way of doing concurrency was introduced in Swift 5.5 with macOS Monterey and iOS 15. You could do it before, but you needed closures and completion handlers, and that broke your code into lots of little pieces. So you would be like, here you send off the URL session task, and then at another place it will complete what happened afterwards. And that was really hard to maintain and to read that code. And the async await methodology makes that much simpler. Also with things like command line tools, which are basically a top to bottom single, this is how we do it. The async and await makes it much easier, because in command line tools, you usually want to wait even for a background task to come back. And that was very difficult to do before. You had to use threads and semaphores and stuff. Now you just have to write await, and your code will pause and continue when you get back the data, which in a simple code is what you want. It simplifies using concurrent code and multi-threaded framework features a lot. So this is the reason that our code will only work with Monterey and higher. Once we get the data back, we can actually look into the HTTP response, because these complex functions return complex data. So we get a response and a data object back from the URL session. And we can look into the response and say, hey, if we didn't get it back at 200, then something went wrong. And in Swift, if something is wrong and you say, I want to throw this up to the higher function, then we do a throw and throw up the error and say, something went wrong with the authentication here. Afterwards, we need to parse the JSON data. And this is where Swift really begins to shine. It looks a bit more complicated here, but the secret is in the decoder. And it is more complicated because it is more powerful. This is the JSON data we get back, whether you use curl or the URL session. This is the JSON data you get back. It has a token in it, which is a very, very long string, which I've abbreviated here. And it has a second field with an expired label that gives me when will this token expire in a ISO 8601 more or less format. It's not quite ISO 8601, but close enough. We want to transfer this into a Swift object. And the Swift object will look something like this. It will have properties for the token, which is a string, and for the expiration date, which is a date. And I want to somehow connect these two in a way that makes sense. And there is an object that does that work for me, and it does really most of the work purely automatically or automagically for me. And the object is called JSON decoder. And that will take the JSON code and create a Swift object with the data. And this is the line that does the actual work. So I created the decoder in the line before, and then I tell it to decode my object, which I've called Jamf auth token, my structure, and to use the data I got back from the URL session request. So that's what I do. I need to do some error handling here as well. There might be errors, of course, if the decoding doesn't work. And because I want a date object, and JSON doesn't actually have date objects, it has strings that look like dates, I need to tell the JSON decoder what its date decoding strategy is. And I need to give it a date formatter for that case. And this is the one that the Jamf Pro API uses. So that's what the extra code is. It looks a bit confusing at first, but it's right there, and it's actually really great. And these are the same 4 blocks that we had in our shell script with curl, and we can put them in Swift. And it's a bit too much for one slide, so I'm not really showing it here, but that's how you put it together, and that's what you can see in the sample code. I can put that in a function. I put it in a static function that belongs to the Jamf auth token class, and that takes, it needs the server string URL, https something.jamfcloud.com, the API username, and the API password. It is an asynchronous method because these HTTP requests run asynchronously, and it might throw an error. And it returns a valid Jamf auth token if it doesn't throw an error. And that's our first object that we built that we can use. Let's call it Jamf auth token. Now that we have the Jamf auth token, we can use it. And I can just use this code in my line, and that will return a Jamf auth token from the server, from the URL with the username and the password. And those are the 4 steps. If I wanted to get another object other than a token, Now that I have a token, I can use the same 4 steps. The preparation will look a bit different because I'm not using the basic authentication. I'll be using the token. But other than that, the steps are basically the same, just the endpoint and the data I get back are different. So I can build a computer object. A computer object has way more data than the token. It will have an ID, it will have a name, it might have an enrollment identifier, an enrollment date, or a model identifier. The object in Jamf has a lot of attributes, and I can focus on what I'm interested in my code, and I can add a function that will return all of these objects from the API into my Swift code, and I can call that a computer. And that basically is already what I need for my command line tool. I'm cheating a bit here. If you look at the Jamf API samples, the JSON return for a computer object is a lot. I can't actually scroll through everything here because Keynote has a limit on how long the field can be. The computer object is one of the most complicated objects in the API. And of course, then my code to get a computer object is also a bit more complicated than what I'm showing here. And I'm not showing this in detail. That said, the principle is the same. And to prove that the principle works, I looked for one of the simplest objects I could find in the Jamf Pro API, and that is the category. You know, the categories, you can categorize applications in the self-service and your policies. Those categories also have an API. And a category has an ID, a name, and a priority. That's all. And I also built a small command line tool that lists categories because it's much, much simpler and serves much better as a first example. You should look at that first and then move on to the computer example. The principles are the same, just that the data returned from the computer object is a lot more complicated. Now that we already know how to work with 2 of the objects, you might think, hey, there's a lot of similarities between these 2 objects. The category and the computer object I built, they have a lot of shared code and shared commonalities. And wouldn't it be great if we had something that could abstract that away, which makes it easier to copy and create even more because there's so many objects in the Jamf API? And there is. And the way to do this in Swift is with a protocol. A protocol is kind of like a contract and says the object I'm going to implement will have these functions and these properties. And you can also, with extensions, give a protocol functionality that will be inherited down to the objects implementing the protocol. Protocols are extremely useful and used everywhere in Swift. And we can create a protocol, let's call it a Jamf object, that implements most of the functionality that the category and the computer share. And then I can focus within the classes on their particular information. And once I have that for 2, I can obviously add more functionality, like I want to update a category or a computer. I might want to delete one if I can. And once I've done it for 2, I can do it for more. And there are so many objects in the Jamf Pro API, they don't even fit all on the screen. But the protocol kind of unifies and the shared behavior between all of these. So this is basically my code for the command line tool. We get an authentication token using the code we wrote. We get a list of all computers that will be an array in Swift, and then we loop through that array and print the information that we want. So we finished the command line tool. That's pretty nice. How do we transfer this into a UI application? The general layout of these applications is I have a list on one side and then a detail view with all the data for the selection in the list on the other. This is fairly common. We have it in the music app. We have it in Finder. There are many database-like apps that have this layout. And it's so common that SwiftUI actually has a pre-made object that I can use for this, and it's called a navigation view. It has a master or list view on the left and the detail view on the right. And we are going to use the navigation view because why reinvent the wheel? We already built objects that talk with the Jamf API earlier for our command line tool. We built the Jamf auth token and the computer. We're going to reuse those. In UI apps, it's easier if you have an intermediate object that controls the access and the initialization of these data objects. These are usually called model controllers, or I called mine Jamf controller because it controls how to get to Jamf and what the data I get out of it. So we built a Jamf controller. Now we need to connect that to the navigation view. And there is a list object. I want to have a list on the right side, and there is a pre-made list object. And I can connect the list object to the Jamf controller, and it will loop through all the computers and get out whatever I want to display, most probably the name. And then I get a list of names in my list object. That's fairly straightforward and actually very simple to do. Now, to fill the detail view, I have to do that myself. When the user selects something in the list view tells the Jamf controller and tells the detail view, and the detail view will also connect to the Jamf controller and get the data out of that single computer object. It will only be talking with one computer object, but it will display all of the data out of that. In this case, the serial number, the macOS version, and the enrollment date. I can also make it editable, so when the user chooses to edit the name and change it, that will be sent to the detail view, and the detail view will send it to all the other objects, including the Jamf controller, who will send it back up to Jamf through the Jamf API and update the data there. Even this is a bit of a simplification. There are more objects involved in this. There's a view for the general app layout. There's a content view that binds everything together. You will have subviews in the detail for info fields. You have to use navigation links. And then while I was writing this, I thought, I really don't want to have my username and password hard-coded in the code. That would be really awful. So I'd like to store it in the keychain. So I needed to write something to connect to the keychain, and I needed to have a UI to enter stuff if it's not in the keychain, and I needed to have a controller to control all that. And as I said earlier, UI applications grow complicated very, very quickly. But you can look at the sample code and see how everything fits together and works together. And we can tie everything together in Xcode. And when you compile it in Xcode on the Mac, you will get a macOS app. And this is what it looks like. As I said, it's a very simple one. I also had a very small and not very full Jamf server here, but I get the information. I can even put in things like icons to represent the fields and relative dates for the enrollment date. The nice thing is, because I use SwiftUI, I get something for free. Because I use SwiftUI and because SwiftUI works cross-platform, I could compile the exact same code and it worked on iPadOS. So this is the same code as an iPadOS app. You see, it looks mostly the same. Some of the layout is a bit different, but it works mostly the same. I don't just get iPadOS for free, I also get iOS for basically free. Because the screens are smaller, the master and the detail view are split, and they move back and forth with animations. But I got that for free because SwiftUI understands the differences and manages all of that for me. So in conclusion, using the API in Swift is not that much different than using it from the shell or from Python or from other languages. We have to walk through these steps. We have to prepare a request, send our request with a URL request and a URL session. We have to handle errors when they happen, and then we parse the JSON data. Parsing the JSON data is where Swift really shines, though you have to know what you're doing. Swift and SwiftUI are really powerful tools for these. They have a steep learning curve, but they are very, very useful. The sample code will show you how to build a command line tool and an app in SwiftUI. And because SwiftUI is cross-platform, the app you build will also work on macOS, iPadOS, and iOS, which is, I think, really, really nice. As I said in the beginning, I will have links to the sample code, to documentation and hints and other things, and once it is published, the video as well, on my personal website, scriptingos10.com, at scriptingos10.com/JNUC2022. And with that, thank you very much for listening. I'm so glad you watched this, and I'm really looking forward to the Q&A and to meeting some of you in person this year. Thank you very much.